medium pressure testing or tightness testing on medium pressure gas meters. My name's Alan Hart, and in the training group we've been asked if we could do a video on medium pressure gas meters and testing for let-by, etc. on medium pressure. And so I've come over to Viva Training Academy today, and we've got Russ, who is the expert trainer over at Viva Training Academy, and he's going to show us all about medium pressure installations, and we're going to try and show you as many different scenarios as possible. We're also going to answer some of the questions that's been asked in the group. So we've had a few questions, we're going to answer them at the end as well. So let's go over to Russ. This video is for gas safe, registered and trainee gas engineers under supervision. Please make sure you follow the current procedures and regulations at the time.
Thanks again for that, Alan. For those who don't recognise me, I'm Russ Holdsworth. Been training for over 20 odd years now, but in the gas industry from leaving school over 40 years, unfortunately. Today we're going to look at medium pressure meters. We've been asked this 2 or 3 times, and there's a certain amount of confusion over the testing of medium pressure systems. In reality, once you get your head around it, it is actually just a series of steps, depending on which meter we've got. When I say which meter, which installation you may come across, that hopefully will be a bit clearer after we've done this procedure. What you'll find is if it's up to date and current, the regulator will have an isolation valve between it and the meter. Some of the earlier ones don't have that, and that's where the confusion comes in, which I hope I can be able to explain to you as we go along here how to deal with that. The procedure is almost the same, it's just a slightly different thing you've got to be aware of because there's no extra isolation valve. Okay, so we've got the regulator on here now. This is an up-to-date one. As you can see, it's got the main isolation valve, the regulator, medium to low pressure regulator, and it also has what they talk about, the meter installation isolation valve, or the MIV as they call it. All the modern ones will have this installation, but some of the older ones don't have this valve, and this is what we're trying to show you today, but the principle's almost the same. We do a series of let-by tests, and this is what confuses people really. Because of so many valves, we need to check the integrity of those valves. So if for a moment we can just sort of pretend this valve isn't here, we'll come to it afterwards, and assume that this comes from the isolation valve through the regulator and then straight into the meter. The idea is, at the moment, because there's no pressure in the system, this under pressure section is closed, and that's why it has a little, what we call a little toggle valve on there, which we'll show you in a second. They all have that. Some have a button, it's the same principle. Some just have a little lever, various ways of doing it. Different manufacturers do it slightly different. We need to check first of all the integrity of the incoming main isolation valve. Don't forget, we're talking anything up to 2 bar behind there. We need to be sure that's not causing a problem. So with the gauge on 0, what you'll find is, as you lift the little lever, the little toggle valve, you'll see a movement on the gauge, but that's only because in here is like a diaphragm, and you're literally pushing that diaphragm open as you lift the lever to open the valve. So it does show a little bit of pressure movement on the gauge. It stops immediately, but that's what's happening when you press it. So as we press that, as we lift the lever, it opens the valve. Now, even though this valve is closed, we're open right through and into the system if it doesn't have the isolation valve. So if this was passing, it would very quickly overpressurise the system. So now we're watching the gauge to see if there's any visible movement on that gauge. They don't always show this in the books now because they assume if you've got the rest of the valve on, you don't need to worry too much about it. But it's just nice to know if you can check it, you can check it. 1 minute, holding the valve open. Holding the valve open, so that it can get to your gauge. Don't forget here, we're testing a high pressure system on a low pressure gauge, so you've got to be able to get that connection between the two of them. It'll very quickly show if it is passing. After 1 minute and there's no visible movement, you can release that lever and it will close down again. Now you can put the gas on. Now this is the tricky bit. It's always the tricky bit. You've got to raise the pressure to the conventional 7 to 10 millibar, and what you've literally got to do is just literally touch this backwards and forwards, touching it until such times as it just lifts enough to get to between 7 and 8. See, very quickly you can go past it. No problem with that. You just release the pressure and do it again. It can take 2 or 3 attempts. It's just a balancing act. Even the British Institute of Gas Engineers will say it may take a couple of attempts. Don't worry too much about that. So letting the pressure drop, and then put the gauge back on again. Still a bit too much in there. 1 second. Gauge back on again, and then the gauge drop down to 7 to 10 millibars. Now we're waiting 1 minute again, watching for that stabilisation to see if there's any rise in the meter, in the pressure again on the state. Exactly the same as you do with a low pressure let-by test, exactly the same. But now you're checking the integrity of that valve. We've checked that valve, we're now checking this valve. From there, we need to do a conventional tightness test. And all we need to do is release more pressure in. Now this time, what you've got to do is take it up to approximately 18, 19 millibars. This one, I didn't find comfortable originally, but the idea is you don't want to start activating this regulator. So by doing it at that slightly lower pressure, it can do a tightness test without any fear of closing that regulator. Once we've established the 19 millibars, we do a conventional 2-minute test, looking for no drop on that gauge. Most of the ones you'll come across nowadays, now just bear in mind this has been set up so it's quite visual. In reality it would always be in a meter box. It will always be external. You never get one of these inside a property. And anybody who's put meters in a meter box or connected to a meter box, we've all gone through the wall at the back. That's a complete no-no on medium pressure. You're not allowed to do that, and the box should be labelled up accordingly. We'll show you the labels shortly. It must always come out of the box and then go through into the property, including, you'll come across this and people ask quite often, what is that rubber tube for? Because we're dealing with high pressure, it does have a built-in overpressure release valve, and that again will be fastened inside the box, and it must come out approximately, well, no less than 25 millimetres out the bottom of the box, purely and simply so it can't just fill up inside the box. I've shown you the old way without the valve. In reality, majority of them you'll come across nowadays will have the extra isolation valve. And as long as the gas is on at the main, which it will normally be when you get to the property, you can treat that valve as your conventional isolation valve, a conventional meter emergency valve. So you can literally treat that in the normal way. Turn it off, put your gauge on, do all your normal checks, pressurise that up to 7 to 10 millibars, your normal let-by test, because you're now checking the let-by and the integrity on that valve. Once you're happy with that, after 1 minute, take it up to your conventional, again, 20 millibars, 20 millibars, and do your normal test again, 2 minutes test. Depending on the meter, that will give you an indication of what pressure drop you're allowed. Remember, existing installation, 4 millibars with this type of a meter. Again, from that point onwards, once you're happy after 2 minutes, turn your gas on and carry on. Exactly the same as a normal installation. The only difference, going back very quickly, is you're talking high pressure, so you need to check the integrity of the incoming valve, the integrity of the low pressure cut-off, which is what that is there. The idea behind that is if you do lose your inlet pressure, that fails safe, so there's no problem with the internal installation. Everything has to be reset before you can establish that. The regulator's preset, and majority will have the extra isolation valve, and you can just treat that as the meter isolation valve as it is. Okay, to recap, remember we're working from a medium pressure main that is feeding into a regulator that converts that medium pressure down to our more conventional 75 millibar low pressure main. From there, we're talking a conventional system, a conventional low pressure system. So initially we need to test the high pressure main. Is that valve going to close the gas off when we close the valve? How do we do that? Connect our gauge, the gauge will show 0, lift the toggle valve and watch the gauge for 1 minute. If that valve is passing, we're now connected directly through because we've physically opened that manually with the lever. 1 minute, no rise in pressure, release the valve, make sure it's closed correctly. We can now put the main gas back on again. 2 bar now up to here, reducing down to 75. We need to now check, is that valve going to pass gas? Should there be a problem? Should it close for any reason? So now we're going to literally just gently take it up to between 7 and 10 millibar. We're on the low pressure side now, so we can do a low pressure let-by test, 7 to 10 millibars, 1 minute timing, 1 minute test. If we're happy with that, we can now close the MIV, meter installation valve, and open this completely. Just literally open it. We're now pressurised 75 millibar or 20 millibar now, which is reduced on the regulator, round to the valve. With the gauge still connected, raise the pressure back up. You may have to drop the pressure out, don't forget that one. Drop the pressure out, raise the pressure back up, 7 to 10 millibar. We're doing a conventional let-by test on that valve. As long as that's okay after 1 minute, we can then take it up to 20 millibars and do a conventional 20-21 millibars and do a conventional tightness test on the rest of the system. 1 minute stabilisation, 2 minutes test. So in essence, we've got that valve is our main valve. As long as the gas is on, there's no requirement to touch any of this. We just need to know what to do if the gas was off. We can work from this isolation valve. So you've got your let-by test and a tightness test. If you do have to do the other two, think of it from that point of view. Instead of 1 let-by test and a tightness test, you've got 1, 2, 3 let-by tests and a tightness test.
Would that gas valve normally be at the back, Russell?
The MIV, various positions, but normally it will be on the front. It's just the way we've got this set up.
And your emergency control valve there, would that normally fall off?
Yes, obviously that shouldn't be in that position. It should fall to the off position.
And you normally have a label on there as well, wouldn't you?
Indicating that was yes, I would always indicated the direction of travel and what that valve was in this particular case, because it is a medium pressure system.
And why do they install medium pressure governors and meters?
The reason in the past has been because of rural areas where there may be a medium pressure main going past the property, and it was easier just to connect onto it. Nowadays they're putting full estates in, and as these estates get bigger and bigger, they're going to need more and more gas, and they can put much more gas through a small pipe under higher pressure than they can by making a low pressure main bigger and bigger and bigger. It's much more reliable to put a higher pressure into those areas.
And why and what are you testing at 19 millibar?
The 19 millibar test on the little toggle valve here is we're testing the conventional low pressure system, but only if you don't have the additional MIV and meter control valve above the meter. As long as that's connected, and literally 99% of any installation you go to will be, as long as it's got that valve, you can operate everything from that valve. You don't need to depressurise the inlet.
And you said about that tube, that clear tube. What's that tube for? And you also you said about, did you say 25mm?
Yeah, the valve, this tube would normally run inside the meter box, comes out pretty much adjacent to where the pipe comes out at the bottom, should stick out at least 25mm, mainly because you don't want any chance of the gas accumulating in the box. When we say, people have asked me, what do you mean the gas? If there was a problem with overpressure, this is an overpressure release valve built into the actual regulator that converts the medium pressure to low pressure. If there was a problem with the pressure exceeding its limit, it would release to atmosphere, and that's why it has to be outside the box so it doesn't fill the box up, and also people, it sounds crazy, but people will smell it and know there's a problem.
And which valve should a customer use to like turn the gas off?
As long as it's got the additional valve here, always advise them to use that valve, because that way there's no way they don't need to worry about that inlet and the resetting medium pressure regulators. That is off, on and off in a conventional way. That's effectively your meter emergency control valve.
And if that did need to be reset, that governor, what's the how would we do that?
To reset the main regulator,
yes.
Normally, as long as the gas has been re-established, you should really go back through your let-by tests again. Check at that 0 to make sure that's not passing. Check the toggle valve at 7 to 10 millibar to make sure that's not passing. Check your meter installation valve, isolation valve with the same pressure again, 7 to 10, and then do a conventional 20-21 millibar test on the outlet.
Right, okay, so you said about bubbles as well. So that part where the anaconda is there, that we would not be able to test that on a normal test?
No, unfortunately, because on a low pressure test, as we all know, we always test slightly under lockup, as in other words, the regulator's not closed. So in theory, we are testing all the way back to the isolation valve. On this, because we have this section here taking the high pressure, a higher pressure out and reducing it, we can't do that. We can't do that. So you must bubble test the inlet. Whatever result you get anywhere else, you must. More important than even a low pressure system, because you cannot check it with a gauge.
And is this the reason why these should never ever be inside a building? Because
exactly that reason. You don't want medium pressure leaking inside a building. That's why you cannot go through the back of the box, because that will give you a connection directly into the building, or worse, if it hasn't been done correctly, into a cavity. So it must be external. The pipework must be external. It doesn't have to be far below it, but it has to be outside the box before it goes into the property.
So we don't want any high pressure gas going into the property?
No high pressure inside the property.
Yeah. And what about labelling? Is this just the same as a normal meter for labels?
The actual meter itself will be, yes, it's the installation around it that will be different. It will be labelled up on the inlet as medium pressure. It may also have inside the box here labelling, say it's medium pressure. If you're aware of the meter boxes, they always have a sort of a cutout here at the back ready for a knockout where you would put your pipe through. That will always have a sticker on it saying must not be used on medium pressure. So you know not to actually, hopefully know not to do that. It'll also have a label down the right hand side here mentioning the pressure relief tube and its positioning.
Yeah, so this just seems, apart from the medium pressure side of it, the rest of the testing and stuff is just the same as a normal.
It's conventional.
It's just a normal test.
Yeah, just be aware is that extra valve on, which 99 out of 100, as I say, will be. I can't remember seeing one out there that didn't have that on, but I've only seen photographs of them. I can show you one, but I've never seen one out there. Most of them have the extra isolation valve. It was early days when they were fitted, so most of them have gone now. They've all got isolation valves.
Well, thanks very much.
Just as an extra bit of detail here. This is, as I mentioned earlier, these valves do come in different shapes and sizes. That's the same thing again now, but with a side entry rather than coming from the bottom. It will always tell you on the front of the regulator, exactly the same as a conventional regulator, inlet pressure and working pressure. This one's saying from 0.3 to 4 bar inlet pressure and outlet pressure 21 millibar. What you've basically got very quickly, as I mentioned on the other section, you've got a two-stage regulator. You've got the first stage, which takes it down to low pressure, and then obviously you've got the low pressure down to our conventional 21 millibar outlet pressure. This other one, there's a little toggle valve. Notice it's slightly different position, but the same principle. Instead of it lifted up on the other one, this one goes to the side. Excuse me, I'll put that down. And the other one, this one, there's another variation of the theme again. Now this one actually is from an LPG installation, an LPG meter installation. And this is the one with the button on. Same principle, high pressure coming in, low pressure coming out. And this one does actually say on it, if I'm very quick, it does actually say up to 7 bar on that one because it's designed to take LPG. But the principle is the same, higher pressure, reducing down to operating pressure on the outlet. What I would like to just mention is, the information I've used today has come out of 2 or 3 different publications. I'm inclined to lean towards, as I've mentioned before, the Institute of Gas Engineers, but the standard training manuals from all the training organisations will give you the same information. Variations on a theme, how they word it, but the principle will effectively be the same. You're doing a series of let-by tests in order to finally get to that one tightness test on the end. The only time to be aware is, does it have the additional valve on it? And if it doesn't have the additional valve, you've got to consider that on the 19 millibar. Other than that, it's a conventional test with an extra 2 let-by tests at the beginning. Thank you.
Right, so first part of the test is, we close the isolation valve. And then we're testing for let-by from this valve.
Yes.
Into the system really, so we hold this valve open.
That's it.
So we're holding this valve open
For 1 minute.
for 1 minute, and what that's doing now, it's manually opening this valve.
Yes.
And it's putting gas into the system.
It's connecting the inlet to the main system.
Yeah, and because this is high pressure here, if this was passing, it would go up on this gauge fairly quickly.
Yes.
Yeah. So now we've tested this now for 1 minute.
Release that.
We'd release that.
Yeah.
And then what's that doing? That's closed that valve back now.
Yes. Now put your gas on.
Then we turn his gas on.
Yeah.
So now we've got as high pressure or as medium pressure now into this pipe, up to here.
Yes.
And this is now closed.
Yes.
And until we go to the system, we make sure everything on the system is off. And then we'd open this valve again.
Very gently, up to 7 to 10.
Gently open this.
Yes.
We take it up to 7 to 10. And that 7 to 10 is testing for let-by again. And then once you've done that, you're then going to do that up to the 20, sorry, not 20, 19, remember 19 on this one. And then, yeah, you can establish it as normal. And then the rest of the system, you do your tightness test as you normally would. So you can do it from the second isolation valve. It's got the second isolation valve. So if you're going to go to one of them valves and the gas hasn't been turned off, then you could just turn the second valve. You can do it from the second valve, and you can just do a tightness test as normal as you would with any other type of domestic system. I hope this video has been of some use and some interest. If you've got any questions, please ask them in the comments below. I've seen one of these meters in 30 years out on the patches, so you're not going to see them very often. So the reason for this video is because you're not going to see them very often, then hopefully if you do see them, then save this video and hopefully you can have a little bit of a recap and hopefully it'll help you. yeah, what I'm gonna do, I've got a little bit of video, a slideshow to do with meters, and I'm just gonna add that onto the end of here. I'm not gonna put no volume over top of it, so what you can do is if you just pause it and then read it as you go, and hopefully that'll help you as well. Thank you to Russ, and thank you to Viva Training Academy for all the help in helping you guys. It's been absolutely, you know, it's been amazing. They've put a lot of time and effort into helping us, so thank you very much for that. Please like, please subscribe, please share, and thanks again.